Good morning. Today we will discuss some topics in information theory and coding, like information examples. And today we will cover some topics like some example of information amount properties. Entropy means average information content of symbol in long independent sequence. And third is property of entropy. We will discuss some example. Here the probability of sending message is pk is equal to 1 upon 4. Calculate the amount of information. How many bits required for information. Then last previous lecture, ik is equal to log base 2 is 1 upon pk. Here pk is 1 upon 4. And then 1 upon pk is equal to log base 10 1 upon pk upon log 2 base 2 base 10 2. Here pk is 1 upon 4 and put these value, and log base 10 is 4 upon log base 10 2 is equal to 2 bit. Means if probability of sending message is 1 upon 4, 2 bits are required for sending the message. Second example is calculate amount of information is binary digits occur with equal likelihood in binary PCM. We know that binary PCM there are only two binary labels, 0 or 1. Since they occur with equal likelihood, their probability of occurrence will be 1 by 2, 1 by 2. So probability of P1 is 1 by 2, it for 0 label, and probability of P2 is again 1 by 2 is 1 digit. Here ik is equal to again log of 2 1 upon pk, and total probability of sending the message is pk is equal to 1. I1 again is log base 2 1 upon pk, and I2 again is log base 2 1 upon pk. Put the value of p1 or p2 also. Here p1 and p2 is equal to 1 upon 2. So here amount of information I is equal to log base 2 is 2, and put all the values in last formula is log base 10 2 upon log base 10 2 is this 1 bit. Means correct identification of binary digit means binary is binary PCM carried 1 bit of information. This is third example. It is very important. Here if there are m equally likely and independent messages, then prove that amount of information carried by each message will I is equal to n bit, where m is equal to 2 to the power n and n is integer. Since all the m messages are equally likely and independent, probability of occurrence of each message will be 1 upon m. Means probability of p1 is 1 upon m, p2 is 1 upon m, and so on. And we know amount of information is ik is equal to log base 2 1 upon pk, and here pk is 1 upon n. Then put these value in formula is ik is equal to log base 2 m, and solve this. And here m is 2 to the power n, and put these value log base 2 to the power n, and power n goes to before the log 2, and here n log base 2 base 10 2 upon log base 10 2 is equal to 1, and here is n bit. So we can solve and we can prove this according to question. Here it is very important. Average information contain of symbol in long independent sequence means it is entropy. To understand concept of entropy, consider we have m different messages like m1, m2, and mm. Then probability of occurrence of messages p1, p2, p3, pm, so on. Suppose we send data in sequence of L messages like M1, M2, M1, M3, M1, M4, M1, M5, so on. Any sequence probability of M1 is P1 is given, but total number of M1 is L, then probability P1L means total probability is P1L. Then says M1 is P1L. Here P1L message of M1 are transmitted, then P2L message of M2 are transmitted, and P3L message of M3 are transmitted, so on, and PML message of MM are transmitted. So information due to message M1 will be again I1 is equal to log 2 base 1 upon P1. Here P1 number of messages of M1, then total information due to all messages of M1 will be I1 total is P1L log base 2 1 upon P1. Similarly, total information due to all messages of M2 is amount of information P2L log base 2 1 upon P2, so on, and we can calculate up to number of n messages or number of m messages is dependent on the question or it dependent on the sequence. So total information carried due to sequence of L message is I total is I1 total means total for I2 and so on, and total for IN. Here total amount of information I is equal to P1L log base 2 1 upon P1 plus P2L log base 2 1 upon P2 and so on, PML log 2 1 upon PM. So average information per message will be is total information upon number of messages. Here number of messages is L, but total information is equal to P1L log base 2 1 upon P1 plus P2L log base 2 1 upon Pa2, so on, and put all the value in given formula. Then this average information is equal to entropy. So we can say entropy is the average information contained of symbol in long independent sequence. Here we use L, and entropy H is equal to summation of k is equal to 1 to m probability of number of messages pk log base 2 1 upon pk. So some properties used in entropy. Here first property we use entropy is 0 means H is equal to 0 if event is sure or impossible, means pk is 0 or 1. Second is when pk is 1 upon m for all the m symbol. Equivalently, for such source entropy is H is equal to log base 2 and m. Then upper bound on entropy H maximum, it is the limit of maximum entropy is log base 2 m. So in next classes we will discuss some examples respect to entropy, and we use some another examples for